This video is just an opportunity for you to do a little bit above and beyond. And I do want to finish off this. I don't want to leave you guys without the opportunity to really see an adding and subtracting problem done out in full and what it can look like if you were to do the entire thing out. And so this is your practice problem. So if you're doing this in order, you have already answered this question, but you probably answered it using Desmos, which is fine if you are allowed to use Desmos. Now, if you're not allowed to use it, that's like another whole thing. But we've got X, and then, and this is not even as messy as it could be because both of the numerators here have a single term. Okay, so there's just an x squared or an x. We could just as easily end up having like quadratics up there, and both of my quadratics that I need to factor are leading coefficient of 1. So again, like we could really up the nastiness level of these problems. But the way this starts is we do need to start with factoring. So we need to find a common denominator, which means we have to get a handle on what our existing denominators are. Now, some of you might be saying, well, why don't you just multiply the one on the left by x squared minus 2x plus minus 15? I could absolutely do that, and I could multiply the one on the other side, and maybe that would work really well in this case. I guess the problem with that is that I would need to then multiply the two denominators together, and that's going to give me a quartic when I do the x squared times the x squared, and that is going to be a really, really nasty multiplication problem. And then if you're doing a multiple choice test and your answers are simplified, now you've got a quartic that you need to factor, and you'd probably have to do some polynomial division in there. So it is in our best interest to factor these first. So for my first one, I have x squared, and then I have a negative 12. I want two factors of negative 12 that add up to negative 1, and that would be negative 4 and positive 3. And so we would have negative 4x and 3x. So this factors into x times x. This is a negative 4. This is a positive 3. So over here, we end up with x minus 4 and x plus 3. And then we've got to factor the other one. So pause if you need to grab that factoring. And we're going to factor the next one. So this is x squared and negative 15, and we want two factors of negative 15 that add up to negative 2, and that would be negative 5 and positive 3. So we'd have negative 5x and 3x, and of course x squared factors into x times x. We have a negative 5 and we have a 3, and again, we could make the factoring on that a lot messier. We could have like the leading coefficient, we could have a lot of things going on. Now, the reason we do that is because I don't want to have to multiply by something bigger than is necessary. So it's just like when you're finding a common denominator for numerical fractions. If you've got, say, like a 2 and a 6, the least common multiple of 2 and 6 is 6. You don't actually have to change both fractions. You could just change the one. Now, could you do 2 times 6 and get a 12? Sure, but it's going to give you much bigger numbers, and you'll have to deal with the simplification when you're done. So by factoring, what I can see now is that these two denominators already have the x plus 3 in common. So to get the denominators to match, this denominator needs the x minus 5. And so what I'm going to multiply by is x minus 5 over x minus 5. Okay, and this fraction over here, this denominator over here, needs the x minus 4, and so this one gets multiplied by x minus 4 over x minus 4, which are like that's equal to 1. All right, now from here it is a matter of, I guess, just multiplying stuff through. So in my numerator, I can distribute the x squared, and that is going to give me x to the third minus 5x squared. And then on my scratch work, if you wanted to see my scratch, you don't want to really see my scratch work, but what I did was I just wrote DEN for denominator because that denominator is horrible and I didn't want to keep writing it down. But for the sake of the video, I will. And so there's my denominator. And then over here, we've got that distribution going on. So we have x squared minus 4x, and I have the denominator here. And so now I have successfully gotten the common denominator. The common denominator is x minus 4 times x plus 3 times x minus 5. And this is not as bad as they can get. Now, when you are adding fractions, you can simply add straight across. And so I'll have x cubed minus 5x squared plus x squared minus 4x. You want to be careful if you have a minus sign. The minus sign would need to be distributed to the entire second numerator over there. And so that is going to give me x to the third. So we had like the minus 5x squared plus x squared minus 4x all over that common denominator, x minus 4 times x plus 3 times x minus 5. And when I did this out, I actually combined the like terms as I rewrote it. So you got minus 5x squared and a plus x squared. And so that gives me my numerator. So that'll be negative 4x squared. And if you are doing this out the long way on a test, like let's say you don't have access to a graphing calculator, you do not have access to Desmos, this is where you would probably stop, and you're going to look at your answer choices and see if you can just match the numerator. If you see one that has a numerator of x to the third minus 4x squared minus 4x and none of your other answer choices do, then you are good to go. That is your answer. If not, then you've got to go through the multiplication of the denominator. So I'm going to do this with an area model. We're going to have x plus 3 times x minus 5. And so that's going to give me x squared, 3x, negative 5x, and negative 15, which you could also get from earlier in the problem, because if you'll notice, negative 5x plus 2x is negative 3x. That is one of your original denominators. And then I'm going to take that, and this is where it's so much fun, multiply that by the x minus 4. And so that's going to give me x to the third minus 3x squared minus 15x, negative 4x squared, what is this, plus 12x, and 15 times 4 is 60. And we have some like terms in there on our diagonal. So we end up with x to the third. Negative 4x squared minus 3x squared is not what I thought I was supposed to have. What did I do? Right here, I made a mistake. That's a 2. Okay. Awesome. I love it when I do that to you guys. Not really. So this is a 2. There we go. Negative 2x squared minus 4x squared is negative 6x squared. And then what is this one right here? This is going to become 8x, right? 8x. Negative 2x times negative 4 is 8x. And then 8x minus 15x is negative 7x, and then plus 60. And that, my friends, is your final answer. Now, I did a little bit of extra work, and I was explaining the work as I went. I can do this problem faster, although I did make a mistake, and I literally just did this problem maybe 10 minutes ago, 15 minutes ago. Yeah, and it took me close to 10 minutes to work through it with an explanation. I can do them faster than that. but without doing the explanation and all the scratch work. But even so, this is still a really long problem, and this is not as long as they get. So you can see again why we save this till the end and why we are very open to alternative ways if we have those ways available. So there is an adding problem worked from beginning to end.